Thank you so much, CascadiaJS, and thank you so much to CJ. You may not know this, but that was her very first talk at a conference ever, and it was amazing. I hope you were paying attention because I'm going to be touching on a lot of the things that she's already talked about, but I'm trusting that you paid attention, and I'm not going to go over it again. So it's not a quiz, but you'll be lost if you didn't pay attention. So for those of you at home, make sure you watch her talk before you watch mine. So stop this now, and then go back and watch that, and then come back. OK. So we already know how many of you want to build a robot, but how many of you have always wanted to build a robot but didn't know where to start? All right, yeah, that's a pretty fair number of you. OK, so first of all, a little bit about me. My name is Raquel Velez. I'm Rockbot on all the things, Twitter, GitHub, blah, blah, blah. And I was a roboticist for about 10 years. Well, actually, I'm still a roboticist, so more than 10 years. I've done everything from the little Lego Mindstorms robot to the huge DARPA Grand Challenge autonomous vehicle and a whole bunch of different things in between. So when it comes to robots, I've hung out with them a little bit. I work at Sauce Labs. It's pretty much the best software automation or automated testing company in the world. So if you want to ask questions about that, we can talk about that. I'm on the mobile R&D team. We're doing really cool things. We're breaking stuff all the time. It'll turn into something awesome, I'm sure. So to recap, in case this isn't going to cover everything that CJ covered, but I think these are the basics. First of all, you love JS. Otherwise, you wouldn't be here. Am I right? Yes? OK, cool. And in case you didn't know, Node, which many of you know, plus robots is NodeBots, which means you can build robots. This is not that impossible. Yes! JavaScript, robots. Why JavaScript? Ask me later. I'm not going to go into that today. But let's build a robot together, because I know how hard it is to get started and kind of go through the thinking process of building a robot. And I don't want you to be scared. I want you to go out and build a robot and do something awesome. So the first thing we need to talk about is what is a robot, right? To me, the standard definition, you're going to find a million definitions. You ask 10 people, you're going to get 10 different definitions of a robot. But if you ask me, it's just a machine that does a bunch of instructions. Pretty simple, right? But what that means, actually, is that there are three kind of categories of robots. The first is a remote-controlled robot. So this is pretty simple, right? It's like your RC car or whatever. You've got a remote control, and you can run it around. It doesn't make any decisions for itself, though. So no big deal. Semi-autonomous is something kind of interesting. It's like a robot that has remote control, but then it also makes some decisions. So the best way to think of this is like the Mars rover, right? So the Mars rover, the scientists kind of say, yeah, I want to take a look at this section of Mars, blah, and because that's how scientists sound, right? Yeah. And then it says, just make sure you don't, bump into anything. And so the robot will say, OK, my mission is to go over there. But, oh, no, there's an obstacle in the way. So let me go around the obstacle to my destination. So that robot's actually making a couple of decisions on its own without any human interaction whatsoever. Then you have an autonomous robot, which basically does all of that deciding by itself, right? So what you would really say is, don't hurt yourself, find something interesting. And it's just going to start exploring, and it'll avoid different obstacles. It has all this decision-making opportunity, ability, artificial intelligence on its own. Autonomous vehicles have very little, if any, human input. Maybe you'll start the robot. Maybe you'll give it some task. But otherwise, the decision-making is completely up to the robot. So you can kind of see how there's a pretty wide spectrum of the different types of robots that are out there. But today, we're going to build ourselves a semi-autonomous robot. This is Batbot. No, he does not fly. This is felt. It's going to be OK, though. You're going to watch his wings flap. It'll be fun. OK, so we're going to give him a little bit of remote control ability, but then we're also going to ask him to make a couple of decisions. And that's going to be really fun because, to me, the really interesting part of robotics is giving your robot the power to make decisions. It's like a child. You're just like, come on, you're ready to leave the nest. Go. But of course, like any good robot, it needs a goal. It needs an obstacle. It needs something to say, I have completed my mission. And so our goal is to see if this robot can find its way out of a paper bag. So, let's get started. Are we ready? Are we excited? Okay. I know lunch is like just around the corner, so just bear with me. There'll be robots. It's awesome. Okay, so first we need to think about hardware. What do we need for our hardware? What do we need for our robot so we can build this whole thing? And as CJ said, Arduino. Let's start with an Arduino Uno. It's a great beginner platform. It'll just kind of, you plug and play and whee. And JavaScript. Yes, JavaScript. Next thing we need is the BOE bot Robot Shield. So I cheated a little bit. I didn't want to build the entire chassis by myself. I didn't want to have to deal with the wheels and the motors and all that stuff. You get this kit, and it comes with all of those things for you. So there's some assembly required. You're going to have to, like, use a screwdriver. You might have to do a little bit of soldering, maybe not really actually any soldering. But it's all there. It's all compact. So that's pretty nice. Now, sensors. Okay, let's have a little conversation about sensors. Sometimes people think that robots just understand what's going on in the world. But the best way to think about a robot is to think of yourself. You're kind of a robot controlled by your brain. I'll let that sink in a little bit. But the idea is that if you didn't have eyes or a nose or a mouth or ears or any fingers or anything, you would essentially be a rock with a brain. You would have no idea of what's going on in the world. So we add sensors to our robots to give us a little bit more understanding of the environment that the robot is in. And so to get through this task, to find its way out of a paper bag, it's going to need to know where the walls are and where the walls aren't. So for that, I've basically come up with 3 potential sensor ideas. We could go with the stereo camera pair, which the basic idea is you've got 2 cameras. It's just like your eyes, right? So you've got, if you were to close one eye and look out at something, and then switch and look out at something, you would notice if you pick one point, like I'm looking at the camera over there, you could look at the screen, me, whatever, you'd notice that there's something, it just kind of moves over just a little bit, right? And so it's the same idea with the stereo camera pair. Basically, you have some sort of local landmark in the picture, and you use some basic math saying, OK, if I know where that landmark is relative to the picture on one side, and I know where the landmark is, which is in a slightly different position, relative to that picture, I know where that is, and I know how far apart my 2 cameras are, then I can actually calculate how far away it is and where it is in relation to me. So it's actually extremely accurate, and it's really good quality. And in terms of price, it's actually not too bad. You just get a couple of webcams and you can get started. But the level of difficulty required for it is actually kind of insane. You have to get some computer vision going on. You got to get some vector math going on. It's a little like, too much work. So the idea is not to scare you on level of difficulty. We just want to build a robot. So then you've got a LiDAR situation, which is basically a laser rangefinder that you can kind of use to get an idea of what's going on around you. The problem with that is that it's not exactly, the quality is not particularly good because you don't actually have any definition of stuff. You just have points on in space. And so maybe you have a 2-dimensional one, so you can get a little bit more of an interesting, cloud of information. But the price is insane. It's so expensive. You want a really cool LiDAR, it's going to cost you $5,000 to $10,000. I don't know about you. I don't have that kind of money, unless you want to give me money, in which case I'd take a check named Raquel Velez. Difficulty, though, it's really easy to use, really easy to put together, great to get data, etc. But again, I don't want to stop you from building robots. I want to get you to build robots. So then we have sonars, which the quality isn't great because instead of a laser where you have a pinpoint, you've got this cone, which doesn't really give you that much information. But it's really cheap, and it's really not hard to use. So you know what? Let's just build a robot already. Let's go with the Sonar. OK, this is your Sonar. It's the Maxbotics ultrasonic rangefinder. but it only points in one direction, right? It just goes out. So to kind of fix that, because we want to know what's around us, we're going to add a servo to it. And a servo is just like a motor, except that you can actually measure, like you know exactly where the motor is at any given point in time. So you can actually program it so that you have your sonar on top of the servo, and you can go to 0, you can go to 90, you can go to 180. And so this is actually a 180-degree servo. So you can kind of get an idea of what's around, what's going on, blah, blah, blah. Here's the kind of scary part. But now that you know how breadboards work, not that scary. And it's actually kind of frustrating. But this is basically putting together you're hooking up the sonar to the Arduino. Everything else is actually fairly plug and play, not too bad. But the sonar does take a little bit of work. You've got to add a resistor and a capacitor and blah. And if you ever want to see the most frustrated adults in a room, this is the best time, because these things are so tiny, and you're like, my fingers are too big. And you're just like, and it's too dark, and you need to have light. And you're like, you 6-year-old, put it in the thing for me. It's awesome. So now, as CJ said, one of the limitations of playing with robots in JavaScript is that you're kind of tethered. Well, we can actually get around that. We can go wireless now, but we need to have a little bit of pieces of, tools and hardware and stuff. And so what we've actually got is the XB shield for Arduino. It's just a shield that goes right on top of the Arduino. And we have the XB antenna. And XB basically uses a radio frequency to kind of talk. And so we've got the receiver end, which goes on the Arduino, and then we have the transmission end, which goes on your computer. And basically, that allows you to kind of replace your USB cable with radio, which is actually quite nice. And then, who doesn't like gaming? At least a little bit. I actually am not a very good gamer at all. But this is handy. And you can actually use a PS3 DualShock controller over Bluetooth to kind of get it to talk to your robot and tells you to do everything you want it to. Of course, you also need wings. It's not Batbot without the wings. Otherwise, it's just bot. And of course, now how do you put it all together? I know you're all wondering, the secret is hot glue. I kid you not, this thing, this stuff is just magic. Because you can put stuff together, and then you can be like, oh, that's in the wrong spot. And you take it off, and then you can put it again. The only problem is, it burns if you touch it, and it hurts a lot. In a recent Twitter poll of solder burns versus hot glue guns, I think hot glue actually won in terms of most painful. So keep that in mind. But put it all together, and what do you got? You've got Batbot. Very exciting. Now, you're probably wondering, how much is this going to cost me, right? And I have decided to give you a parts list fully. And $400 is not a small sum of money. But if you think about the amount of money required to put together, say, an autonomous vehicle, $5 million, this is actually quite reasonable. I mean, it's probably not going to go from LA to Las Vegas in under 10 hours by itself in the desert, but maybe it'll find its way out of a paper bag. Maybe. All right, so now here's the fun part, right? Software. So we've got the hardware all done, great, no big deal. But now let's get to the stuff that we actually know, we know really well. Let's get to the JavaScript. So step one, we want to use some Johnny 5. Hopefully, yeah, okay. So it's pretty nice, pretty simple. You basically, for all intents and purposes, instantiate different your servos and your sonar, and you give it some parameters that it needs to know. But that's basically it in terms of getting it started. Just a couple of little, set things up. Great. Moving on. For the XB wireless, we do have to add an extra little bit of port information because we're using, instead of just a regular USB serial, we've got this fancy one. Whatever. And then the PS3 DualShock controller, I love this DualShock controller NPM module. It's really nice, really easy. It's literally just ds.on, pick a button name. When you press it, when you release it, make it do stuff. Yay! If you're wondering about turn right and stop, those are functions I actually wrote, but they're in the code base. You'll see it in a sec. Now here's the really interesting part, right? Logic. How should this robot think through things? And just like a machine, it will do exactly what you tell it to do. So think about what you want it to do before you tell it to do it, because then it might just find its way off the stage and go ah. I really like the temporal library for this. It basically, instead of using set timeout and set interval all the time, you can actually use some ES6 fancy schmancy shenanigans to get things to go in the order that you want. And that was written by Rick Waldron, also the creator of Johnny 5. But the big piece here is I'm trying to use a wall follower algorithm. And the idea behind that is the most basic wall following thing ever. If you think about it, this is the easiest maze you've ever seen in your life. I guess slightly easier would be just 2 walls. You just walk right through. But 3 walls isn't bad. We're going to ignore the top and the bottom. But, for whatever. So the idea of the wall follower algorithm is that if you just pick one side, right or left, and you follow the wall of a maze, as long as it fits a couple of certain requirements, it'll take you forever, but you'll get through the maze if you just follow it with either your right or left hand. So we're going to try to convince this robot that as long as he follows, when he hits an obstacle, if he just turns right, you'll be fine. You'll get out eventually. But then otherwise, the goal, the general logic is look left, look straight, look right. Whichever wall is furthest away, go towards that one. Pretty simple, right? Let's see if he agrees. So just like any child, no offense to the children in all of us. Oh, dude, this is robots. It's fine. Okay. All right. They make their own decisions. We've given it the ability to make decisions. It may not work all the time exactly the way we plan. But at least we can move it around, and we can, All right, we're going into the bag. Are you ready for this robot to go in the bag? All right, so I have this little, it's on select. Then when I press select, it will make its own decisions. Can everybody see the robot? Let's just do this. Can we? All right, so you've got a robot in a paper bag. All right, this is super exciting. Batbot, don't let me down. These are my friends. All right, let's go. It's going to take a few minutes, he's thinking. Oh, can you hear him? Make a decision. Anytime now. Oh, okay, it turned. All right. Seems it turned to... Okay, that's good. Come on. No, it's okay. It's okay. It's shy, you see. What if we just kind of force our hand here? Okay, yeah. Yeah, that's good. Uh-huh. Yeah. Oh! Excellent. Stop moving. Thank you. He did it! All right. Good job. Thank you for not making me look like a complete and total moron. I appreciate it. After some time working with robots, you start to refer to them as people, and you have conversations. You just witnessed a little bit of crazy, I know. But now it's your turn. I leave you to play with Batbot, or any other type of bot. Hopefully you've seen that this isn't actually that hard. It's just takes a little bit of burning of your fingers with hot glue and a little bit of cutting out of felt and, OK, buying some parts on SparkFun and plugging everything in. And then you get to code, which is really the fun part. And then you get to see if it can do something really cool. So I implore you, I beg you, I hope that you will go out and play with robots. And if you have any questions at all, come get a hold of me. I try to be as extremely responsive on Twitter as possible, but all the code is on GitHub. Go, have fun, Batbot on.